Okay, hello everyone. Good morning, good afternoon, good evening. Pending when you get to watch this video. So my name is Innocent, and this is the CyberOps Associate. Okay. Um, so still on the lab. So today we'll be looking at three labs. So we'll be taking three labs, and we'll be learning what encryption is all about. Okay, we'll be looking at a tool called OpenSSL, and we'll be using it to encrypt and decrypt a file. Okay, um, we'll further try to crack a zip file in this second lab. Okay, and then in the third lab we'll be looking at let me show you. We'll be looking at snot and firewall rules. So you see how to set up an IDS real quick, and then how to apply firewall rules to it. So this lab is going to be packed, and then so let's get started with the first lab. So stick with me as we encrypt and decrypt some data. So first off, you want to open up or start up your CyberOps machine, and then while you've logged in with your username and password, now you open your terminal. Okay, and then of course OpenSSL is there, but you can cross check and just type OpenSSL help. You know, so yes, this is OpenSSL. These things you can see here are the encryption algorithms. So let me clear my screen. So first of all, before we continue, we need to know what encryption is all about. Okay, so encryption is simply the process of converting readable data. So readable data like your plain text, your Microsoft Word. So those documents in plain text. So encryption. So you convert readable data into a scrambled, unreadable format, which you call ciphertext. Okay, so and before you can be able to do this, you need to use an algorithm and cryptographic keys. Okay, so you use algorithm and cryptographic keys, to convert your plain text to ciphertext. Okay, so OpenSSL is going to enable us to be able to convert plain text into ciphertext. Okay, so we are going to start now. So first of all, let's go to our lab support files. So if I press CD and then CD lab support files, and once you are here, and then there's a file I want us to open. If I do ls, there's a file I want to locate, which is letter to grandma.txt. So if I show you ls-l and I say letter to grandma, you can see it's just an ordinary text file. So let me decide to run file on letter to grandma. So of course it's ASCII text, so it's just an ordinary text file. So let us cut it and see what it's all about. So we'll see that this is just a pretty written letter to grandma that says, "Hi grandma, I'm writing this letter to thank you for the chocolate chip cookie you sent me. I got them this morning and I've already eaten half of the box. They're absolutely delicious. So I wish you all the best. Love, your cookie eater grandchild." Of course. So we want to be able to encrypt this data, because as a cybersecurity analyst now, you might be in an organization that works with critical data. You want to be able to encrypt that data into a format that nobody else will be able to decrypt it. Okay, you want to be able to encrypt it in a way that it's safe, right? Because you don't just encrypt. During the encryption process, you need to add a password to be able to remember to be able to decrypt it later on. So so first off, let me show you how to encrypt this real quick. So we're going to use our OpenSSL, and then we're going to specify the encryption algorithm. Okay, so we're going to use AES 256 CBC. Okay, if I show you this, I think I showed you the first time. Then you should let's ask for the help option, so to see whatever command you want to use, cipher commands you want to use. Okay, if we are checking for hash, I can just use this, but I want to encrypt it, so I'm going to be using the AES 256 bits. Okay, so let's go. So open SSL AES 256 and then CBC, and I will specify the in, that is the letter to grammar .txt, and then I'll specify the out -out, which is going to be message. It's not there yet, so this is what I want it to be like in the form. So this is a simple command. So I'm just saying I want to use OpenSSL to encrypt this file, this input file, and produce this output file. But then you use the algorithm of what AES. Okay, so 256 bits. So if I press enter now, it's going to ask me for my password, encryption password. I can just say, okay, let me just use Southtech. But of course, you want to use a very strong password. Don't be like me, please. So Southtech, and then it asks me to verify it. If it is not correct, then it will not, it will not encrypt. So if I do ls now, /l message, we should be able to see it here that, oh, this is our message.enc. So it's been encrypted. Let me try to run file on message. So you see it's an OpenSSL encrypted data, okay, with salted password. So so if I cut message.enc, it will be gibberish, because you won't be able to access it. It's just encrypted. So this is what encryption looks like. So now we are going to try to decrypt it. Okay, we're going to try to decrypt it. So I think there's another format again where you convert it to where you use base 64 encoding to make it instead of this. It's I don't know, this is like another format to encrypt. Let me just show you real quick. But this is one way to do it. Okay, this is one way to do it. But you can also, let me remember my previous message, you can also apply the -a to add the base 64 encoding bits. So after it's going to do this, it's going to now encode it into base 64. So if I press enter, it still asks me for this, and I can still say Southtech. So this is still encryption, by the way. I'm not decrypting yet. Okay, so press enter, it asks me again, I say Southtech. So now let me show you the difference between this and this new one now. So if I say cat message, you see it is at least it's still pretty, but it's still gibberish, but this is now base 64 encoded in a way. So this is like after encrypting, you're now encoding it again into base 64. Okay, so now let's see how to decrypt this. Okay, let's see how to decrypt this. So to decrypt it, I'll pull up the previous command, and you see it's still identical. So first of all, open SSL. We're going to specify our encryption algorithm. Okay, we're going to specify that I want to use base 64. What you specify now is you want to decode. After specifying base 64, you specify you want to decode it, and then you also specify the input file. This time around, the input is going to be message.enc. Okay, because the input file is the file we want to decode. Okay, we want to decrypt. So message.enc, give me a second. So if I type it, it complete. So message.enc, and then we can see how to be decrypted. Decrypted. If I can type CRP decrypted dot now you can call it decrypted letter.txt, because it's going to be a text file, because we already know what was there. Okay, so it's a very pretty easy command. So open SSL AES 256, or specify the base 64. You say you want to decode it, you want to decrypt it. We'll send in the input file of the encrypted message, and then the output file of the output file that we expect. So this name can be anything. Just make sure it's in the TXT, and then if you press enter, it's going to ask for our password. I'll put our password. So let me just type in the real password first and see what happens. You see bad decrypt. Okay, so there's nothing you can do about it. So let me just type in our correct password now to see it work. So Soundtech, and then we get this. Okay, so now if I cut the encrypted letter, if I cut the encrypted letter, if I can decrypted letter.txt, right, and then we'll get this. Okay, so we've seen how to encrypt and decrypt. So this is the encryption here. Okay, we are encrypting our TXT file, and it becomes message that encrypted. Then you can delete your TXT file, so that you don't have two files there, the encrypted and the decrypted. So now you've seen this. So this is our clear text, this is our ciphertext. Okay, so this is basically what encryption is all about. Converting readable clear text into ciphertext. Okay, so this is what encryption is all about. So if I clear my screen, if I do ls-l, you see all this, you see our decrypted letter. Okay, so this is it. So this lab is very pretty straightforward and very easy. So this is encrypting and decrypting data with OpenSSL. So in our next lab, we're going to see how to encrypt and decrypt data using a hacker tool. So we're going to create and encrypt files and recover our encrypted zip file password. So stick with me. So hello everyone. So this is the second lab for the day, and now we'll be learning how to crack a zip file. We'll be learning how to recover a zip file password. So why would you want to crack a zip file? Not for anything malicious, not for anything unethical. If you are, let me say, you are working in your organization, and your boss mistakenly forgets his password or something like that. As a cybersecurity analyst, your job will be to to be able to recover these passwords. Okay, and then we are going to be following the step-by-step guide. And then please stay with me as we go through this. Okay, so first of all, I would like us to create a text, and then put it in a zip file with password. So let's do that. Let me show you what I mean. So I'm going to echo out some text, which is going to be let me see, please never give up on learning. Okay, so please never give up on learning. And I'm going to echo this to sample. Let me call this sample1.txt. okay, so I'm going to create three sample files. So sample1.txt, the second one is going to be sample2.txt, and then the third one is going to be sample3.txt. okay, I've showed you how to echo out stuff. In case you are just watching this for the first time, I think you should please check out the previous videos, okay, our previous streams, to be able to catch up with whatever I'm doing here. Okay, and where I explain this in detail, and then this is called the redirection sign, so you understand better. So now if I do ls-l, you will see we have three txt files here: sample1, sample2, sample3. And then okay, so what I'm going to do next, I'm going to try to put these sample files into a zip file. Okay, so let me show what I mean here. I'm going to use the command zip, and I'm going to say I want to create a zip file of what, file1.zip. okay, and then I want to say everything has to do with sample. So this is where the asterisk comes in now. If my shift will allow me, good. So this is where the sample comes, the asterisk comes in. So I'm saying everything that has to do with sample, the asterisk, sample dash asterisk, that is sample 1, sample 2, sample 3. I want you to put them into a file called file1.zip. okay, and then this file1.zip, if I press enter now, it's going to ask me for password, and then now I can say okay, now I want to start giving my password. But for now I'm going to use a very small password because we want to be able to crack this password later. And then since we are just learning, we are going to see how to crack password from a low password that has low strength, that is, let me say, 1 character password or 2 character passwords, and then we'll gradually increase the strength of the password. So let me show you. For this I'm going to use an A, or let me use dots, press enter, dots, and press enter. Okay, I've seen people using dots. Some people be like, oh, it's just a dot, nobody is going to think about dots. Okay, so now if let me show you ls-l file1, you see file1 has been created. So I'm going to do the same again, and I'm going to try to create for file2.zip using the same text. It doesn't matter, it's just the zip file that is the that is what we are going to crack. So it doesn't matter what the text in it means, whatever the text is. So this is file2.zip. Now it's going to ask me for that password again. So I'm going to say, oh, let me increase the character length now. Let me increase the strength of my password to 2 character. I'm going to say let me use the letter A1, and I press enter. I'll use A1 again and press enter. Okay, now I have, let me show you, that ls-l. You see I have file1.zip, file2.zip. okay, first of all, let me try to let me just create more files so we have it in one place. Let me create another zip file, file3.zip, and this time I'm going to increase the strength of the password to 3 characters, and then I'll call it 0r dots, and I'll press enter again, 0r dots, and press enter, and then it has been created. Okay, and then for the last one I'm going to say file4.zip. okay, file4.zip, and then let me increase to 4 character passwords. Let me say rain, and then press enter, rain, and press enter. So if I do ls-l now, we now have these 4 zip files. Okay, these 4 zip files, and then and let's see, let me try to unzip this first file and see what happens. So if I say unzip file1.zip and I press any password, of course I remember the password, but let me just put in hello. It shows password is incorrect, hello. So of course it won't work. So you see it's still incorrect because we're not getting it. Okay, so what I want us to do now is to crack these passwords now. So this is where I'm going to introduce you to a tool called fcrack. Okay, so it's called fcrack zip. So this tool now is used to crack zip files. So like I always tell my students, anytime you encounter a new tool that you know nothing about, that is new to the industry, and then everybody is jumping on the bandwagon, and you want to figure out what the tool is all about, always read the manual. You can use fcrack zip. If there's a manual page for it, it's going to show, but there is a -h for help, so you can also use it also to seek for help. Okay, So you can see that fcrack zip is a fast, free, zip password cracker. Okay, it's written by this guy. Okay, so you can find more info on this. So I'm giving credit to the creator, of course. So now these are some flags you can use with the tool. Okay, so you can use dash b to brute force. You can specify the variables, you can specify the length, but this is one of the things you'll be using, things like this. So let me show you. Let me now start cracking. Okay, let me get cracking. So fcrack zip, and then I'll say I want to use the small letter V for variables to show me more information as it cracks. I want to use the dash U to use unzip to read out wrong password. So it's going to read out wrong password, that's U. And then I want to specify the length of the password. For example, I might not really know the length of the password, but that's why it's a guess. And sometimes you can see there's something called shoulder, I think shoulder surfing or something like that, where you try to take a peek at somebody as the person types in his password or stuff like that. So you can just figure out the length of the password one way or the other. In case you don't know the length of the password, that's fine. You can start doing guesswork. But for now, I will say okay. I want to use the length of this dash L flag. I want to use the length of 1 to 4. Okay, so its length should be between 1 to 4, and I want to specify the zip file, which is file 1.zip. Okay, so this is for the first file. Remember, we've created four zip files. Okay, 4 zip files, and so now I want to crack the first zip file, and then if I press enter, watch this, file 1.zip. Okay, so we get this. Okay, let me show you for file 2. I don't know what is wrong, but it should be fast. Okay, good. This one actually worked. I don't know either I didn't type anything or something was wrong, but it should have cracked it in less than a second. Now you look at this second zip file. You see it cracked it in less than a second, and it's a 2-character password. Okay, look at how fast it cracked this. And again, there's nothing called brute forcing, whereby, let me say, if you want to use this, you can use brute force. You can use a dictionary attack where you specify a word list and then you try to crack it based on those words. So you can also create your own word list and then pass it onto fcrack for it to crack it for you. So this is to see how fast it's cracking the password between the 1 to 4 lengths for file 2, and it figured it out that it is A1. This is just a 2-character password, and then I can do the same for file 3, and let's see if it figures it out. Okay, so the longer the password, it now starts taking time. So this is a tool you definitely want to play with. Okay, this is not something I wouldn't advise to crack passwords in your virtual machine like this. Okay, so a lot of things can go wrong, apart from because your CPU is shared, okay, between your main machine and then the VM. So sometimes real hackers will set up a very, very powerful system like that if they want to crack real life passwords. So they'll set up a powerful system and then pass in the tool to it. So system that has a good amount of processing speed and processing power, and then GPU speed also. So some tools will use GPU to crack, and if your system has a GPU, a graphical processing unit, then you should be able to crack your passwords very, very fast. This is one of the reasons why the hackers will always tell you, and they need a fast computer, they need a very, very good computer. So this is pretty much it. This is pretty much what cracking the password looks like. So it's just going. This tool is going to use its hand to generate passwords between the lengths of 1 to 4. So you can keep on increasing the length, and the more you increase the length, the more time it's going to take. Okay, so the more time, if you look at this one, you found the word rain very quickly. So you see, and you can also create a 5-character password and then it's going to crack it. But the point is, the let me say, the longer the passwords, the more time it's going to take. Okay, So you need to keep this at the back of your mind as you crack your password. So this is it for this lab. So again, why would you want to crack a password? Not because of anything malicious, but because there will be a time when you want to, recover some of your zip files, and maybe you have forgotten the password. This is one good tool to use. Okay, or your boss might say, oh, since you are the cybersecurity analyst of our company, and then you should know how to do this. Okay, I forgot the zip file to my to my Word documents, to my this. Please crack it for me. So yeah, this is a good tool to have, to keep at the back of your mind, or to hide in your arsenal. So thank you for this lab, for sticking with me so far. So in our lesson now, we're going to be saying how to play with snots and firewall rules, and then understand what it's all about. So thank you. Okay, everyone, welcome to the last lab of this section. So this time around we will be learning how to set up snots, and understanding what a firewall is, and then the firewall rules. Okay, so first of all, let me explain this network topology here, because we'll be simulating something similar to this, what you see here, using a Python script. Okay, so the script is already in our CyberOps workstation. It's already there. I will show you where to locate the scripts and how to run it to simulate this environment, and then we'll be applying similar concepts that we can see here. So let me just explain what we have here. So in this topology now, you can see we have two routers. So this remember, every interface in the router is a different network. So this is a different network, this is a different network, this is a different network, this is another different network. Okay, and so ultimately they can't communicate unless there's a routing protocol configured in this router. All right, let me say for example RIP. Okay, a routing protocol, routing information protocol. So so now this is one internal network, another internal one, but this one for servers. So let's say this internal network now tries to send in data. Okay, so any data coming into this router will be so let's say the ingress. Okay, so it's coming, this is the input chain, for example. That is if in terms of firewall, because you can see this router also has firewall and IDS implemented in it. Okay, so it's going to be monitoring for traffic coming into it. So this should ultimately be the input chain. So any data coming into any traffic coming into the router will be the input chain. Anyone coming out of the router is going to be the output chain. Okay, for example, if this device pings this router, this is an input chain coming in, and then the firewall, the IDS, is going to monitor the traffic and see if it's anything malicious. Okay, monitor the input chain. That's if you set it up for the firewall, and then the router can now respond to the ping, for example, for this router 1, for this host 1, and then that's the output chain. So I'm just explaining the concept of chain. Now we'll still see it in a moment, but the reason I'm explaining the chains here is because if you can see in this other network now, this is an ISP now that supplies internet access or something else, and then there are other hosts connected to the ISP now. Okay, so now this, and if you look at this host here, you can see the attacker's machine. There's a web server now here that is hosting malware here. Okay, let me say for example now this attacker sends, he has hosted his malware, and then he tries to send it to an internal user. Let me say H1. Okay, and he sends it by phishing through their email or something else. Okay, it might not pass. It doesn't necessarily have to pass through the same link. It just goes to the internet, and then it gets to them in a way, in maybe their private email, and then they now open it now in their work computer now, and they now open it, and then they now discover that the link is sending them to download malware from this from this web server. Okay, so now this, because the traffic is going to pass through this ingress port of the router, and tries to reach, so the router should be able to figure out, what's going on, what kind of traffic is this, what kind of traffic is this, so the idea should just be able to analyze the traffic and figure out what's going on. Okay, and then the idea will send alerts. Okay, the idea is we should provide alerts, and then if you've set up your firewall to block traffic going to the web server, for example, of course you should be able to block it, so you won't be able to download malware. All right, so now let's start up our scripts and then implement all this. So as we write on now, you understand it a lot better. Okay, so let me move this aside, and then as we start working with our script. So first of all, let's open our terminal here. We need to open our terminal and then locate our script. So you need to be connected to the internet. If you are not connected, let me show you how to quickly set up your internet connection. So you use DHCP. So let me say slab support file scripts. You need to be connected to the internet. Okay, so let's configure as DHCP. This should set up DHCP real quick for you, and then you should be able to surf the internet. Okay, give me a second. I think it has already done this before, so let me try to ping Google and see if it connects. Okay, I'm connected to the internet, so no need. I'm good. And so what I'm going to do now is I'm going to start up my my network, my mininet process. Okay, so it's going to be in my lab support file. So let me go to my lab support files scripts. Okay, and then I'm going to run this. Let me show you the file I want to run. I'm going to run this CyberOps extended no firewall.py. I'm going to run this. So I'm going to say sudo /cyberops _ extended topo, okay, _ no firewall.py. So this is the file I want to run. This is the script I want to run. So if I press enter now, it should now start configuring minidets for me and setting up the hosts. As you can see now, we have so many hosts, 2 routers like you've seen before, and then this many amount of hosts. Okay, so 11 hosts, similar to what was in the diagram. So now what I want to do now is I want to start up the router 1 and set up our firewalls and I'll set up our IDS, our intrusion detection system first. So I'm going to start it using xterm. We've seen these commands before. We've seen minidets before from our previous labs. So if you are still confused about this, or you are just joining us for the first time, please check up on our previous labs to be familiar with these commands and then to know what's going on here. So I'm going to open this router 1. So now we have our router 1 here. Okay, and then in my router 1, I want to start my intrusion detection system. Okay, I want to start my IDS. Okay, so the name of the file I want to start is in small caps. I want to start snots. Okay, this will be my IDS. Okay, I want to start snots, and if I press enter, you see snots starts. Okay, so now every traffic that flows through this router, now let me show you, every traffic that flows through this router is going to be monitored because I've started up my IDS. Okay, so it's going to be monitoring my traffic, and then any malicious access is going to detect it. So now that our IDS is running, let me now pull up 2 hosts. Let me start up 2 hosts. I'll start the host. I want to start H5 and H10. I want to start two hosts, host 5 and host 10. Okay, so this is host 10 and this is host 5. Okay, so host 10 is going to be hosting my malware, like I showed you just now in the picture. Host 10 is going to be hosting the malware, while host 5 is going to be doing the downloading. Okay, so this is something similar. So my host 10 now, and I want to start up the malware server. Okay, and it's going to be, and the name of the server is mouseserver.sh. mouseserver.sh. But first of all, let me cut this mouse server and show you that it is just a basic script. So mouseserver.sh. So basically, if I start this mouse, I've not started it yet. I'm just viewing it in the terminal. Okay. If you don't still understand what all this is, what all this means, you need to check our previous tutorial to understand what the cat means and how to use the basic Linux shell. Okay. So now, what this my mouse server is going to do is going to pull up Nginx, because Nginx is a web server application. It's going to pull because it's going to be hosting it with Nginx. So of course I need to start my Nginx first, and then it's going to be loading from the configuration file of mouseserver.conf in where the Nginx is located. So it's basically going to be starting the mouse server with Nginx. Okay, so now let me clear it and now start my mouse server. Okay, and then it has started, but it didn't show any information, no further distance. But just to make sure it started, let's use our netstart. You've seen this command before. Let's use our netstart to cross check. Okay, using these flags, these many flags. So we're going to use netstart to confirm that Nginx is running in the background. So if I pull up netstart, should be able to see this good. So now look at Nginx. It's running with this. Okay, so it's running on port quadruple 6 in its local hosts. Okay, so now what I want to do now is I want to now pull up my alert. So now this is router 1, and my H10, my malware has started. Okay, I'm not downloading anything yet. Now I want to be able to monitor for my alerts. So what I'm going to do is I'm going to pull up another router 1 again, xtem router 1. Okay, I'm going to pull up another router 1, and what I want to do now is I want to monitor for alerts. So this is the reason why I said you use tail and more when working with when working with log files and alerts. So it's preferable than using cats. Okay, so so now I'm going to use tail. I'm going to show you what this is. So what tail is going to be doing is it's going to follow using the -f flag. It's going to follow the IDS, the snot IDS. Okay, so I'm going to monitor for the log, varlog, snot, and then alerts. Okay, so stick with me. This is a very, very technical and interesting lab, so stick with me. So now I'm going to be monitoring for the alerts. Now because I've done this before, we are getting this, but just don't worry about it. Okay, because I was making sure nothing is broken in this particular lab, because it can be tricky. But I'm going to redo the whole process so you see what is happening here. Okay, so now our alert is being monitored. Don't worry about this. So what I want to do now is I want to now try to download malware from this malware server, which is this H10. Remember, H1 router 1 is our router and also our IDS. Okay, so it is running our IDS here, and also it's going to be popping up our alerts here. So in case of any malicious link to this server that has already been configured in the IDS, it's going to pop up and show us that, oh, we are trying to access this, please don't do that, or please be careful, stuff like that. Okay, now let me try to download the malware. So I'm going to go to my home, so pwd, I'm in my root. Okay, so remove. Okay, let me just leave it there. Let me clear my screen. Now let me try to download using a tool called wget to get things via the terminal, to download things via the terminal. So I'm going to say I want to get let me show you the IP address of this host. So I'm going to get stuff from this host IP address, so it is 209.165.202.133. okay. I want to download from this in ports. Remember the ports, okay, quadruple 6 or 6, and then this is it here. This is the port here. So it's not magic, it's running within these hosts. Okay, so I want to download file. Because I know the location of the file, I'm going to specify it now. So I'm downloading from this IP address on this port. I want to download this file. What's it called? w32 .nimda.amm.exe. So give me a second. .amm.exe. So this is what this thing looks like. This is the direct path to the malware. I know where it is hosted, so I can just but this is the path you would take ordinarily to download this thing, the malware. So now if I press enter, it's going to start downloading this malware, and then you should now just keep your eyes here. At the same time I press enter, so you see how it downloads the the malware. So I press enter, you see, and you just got a hit. Okay, now we are saying, oh, look at this, this file has been downloaded here, no problem. But what you are seeing now is, whoa, there's been a malicious server hit, blah 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 blah. Okay, so now if I do ls, if you see, I've already downloaded it twice, so I can remove all these other ones. But if you see here, this is our file here. Okay, so if I remove, let me show you. Okay, and then so let me show you. If you see, this is our file here. It's been downloaded. Okay, it's been downloaded, and then what our IDS actually detected it, but it did not stop this tool from downloading the malware. Fine, the IDS caught it, but this is where having an active cybersecurity analyst comes in. If you set up an IDS, you should be able to know when an alert comes in. So this is the reason why this alert is also is popping up here, you see, because we've also set up tails to actively monitor, to actively follow the alert file, so it's monitoring it. Okay, and then now that this file is downloaded, if this host installs it, of course the host will be compromised, because nothing can be done unless the host now has a very active antivirus, or some other very good protection like that. But if the attacker knows what he's doing, and he has done his recon and figured out that this host uses specific software that is vulnerable to so and so, and he has crafted his payload to specifically target this host, even though the IDS blocked it, once the host installs it, the attacker can still gain remote access. Okay, because now the IDS only detects. We've not set up our firewall yet to block the incoming to block incoming and forwarding chain, to block incoming and forwarding traffic. So what I want to do now is now that we've seen how to detect this, I'm going to try to set up snots. Okay, I'm going to try to set up snots, but for now, first of all, let me monitor my traffic using TCP dump. Okay, let me show you, because it's a good idea as a cybersecurity analyst, because even if, let me say this is your host machine now. Let me say this is your machine as a cybersecurity analyst, and then you receive a file, though your alert is still there, and then somebody is targeting you. and if let me say you have your Wireshark or TCP dump running in the background, which I'm going to do now, you should not be able to let me see if for example the attacker succeeds and then compromises you and then clears all the evidence of w32 nimda.exe and clears and deletes it, and then the file is gone. But let me if you were monitoring traffic, or maybe say you started TCP dump earlier and then your dump is just listening for connection. Let me see, I'll use the H5 because I know the interface already. Let me show you. And then I want to monitor the traffic flowing through this device now, and then I will say I want to write the file to nimda.downloads, okay, .pickup, okay. So I want to run this in the background, okay. So I will use my ampersand. So you should always a typical work of a cybersecurity analyst will be to be able to be monitoring traffic like this, to be dumping every traffic. Maybe once in a while you just run it to dump all your whole traffic, everything that's going on in your computer or on the router. So if you run this kind of command now and I press enter, you will see it is listening on this interface, and then every traffic will be dumped in this nimda.download.pickup. So now I can still make use of my terminal here, but in the background it is recording my every traffic flowing through this device. So now if I try to download that file again using wget, okay, now the traffic has already passed through this system, and so my TCP dump that is already listening on this interface will capture it, okay. Even if I stop my TCP dump now, let me show you. If I do FG to call it up, you see it's showing that, oh, this is what is running in my foreground. So now I can now use Ctrl+C, okay, to stop it, and now we'll get 59 packets received by filter. And so if I show you ls-l, you should see my nimda.download.pickup. So this pickup now file, you can now open it in Wireshark at any time you want, and then examine the traffic, okay, and maybe maybe some other time, So this, if you know what you are doing, you should be able to extract this same exe file now that has flowed through the traffic. You should be able to re-extract the exe file from this captured file. You should be able to extract the malicious exe file from it, okay. So this is where you need your expertise in Wireshark comes in. You should really know how to extract your exe from this packet captured file, okay. But this is it for this, maybe for another lecture or for another tutorial. But for now, what I want to do now is I want to set up my firewall, because you notice the IDS only detected the intrusion, you see. So sometimes even if there's an intrusion detection system, you also need firewall to block those kind of traffic, okay. So now this is where my firewall is going to come in now. So first of all, I'm going to open another router, another node router, because this one is already listening. This one has already started my snot. This one is already monitoring the log files, while this one I want to start up now is going to set up my firewall. Remember from the previous the diagram I showed you, from this diagram, let me show you the diagram. For this diagram, this router has both the firewall and the IDS, okay, and that is what we are kind of simulating here, but in practice now, okay, and with more efficiency. All right, so I'm going to set up my firewall now to be able to block any malicious traffic now. So now this has started. Let me execute IP. So the tool we're going to be using is a Linux tool called IP tables. So we're going to be using the Linux, the default Linux firewall capture, okay. So if I do IP tables and then specify the list chain, okay, to list the chains of course, and then use this dash v for variables, and then if you see this, you will see that we have input chain, forward chain, and output chain. This is where I was talking to you about chains now. So input chain is going to be any traffic coming into the router, okay? Output chain is going to be any traffic going out of the router. But then forward chain is going to be, for example, like your when the router is routing, it's routing traffic. It could have happened from any device at all, from anywhere in the network. So it's just going to forward any other traffic, okay, like your routing, or like when the router is performing routing from another totally different, router network entirely. So I'm going to set up this now. Now that I've seen the chain, so I've listed the chain, I'm going to set up my IP tables now. So IP table is going to be our default firewall, of course, like I've said before. So let me set it up. Let me show you. So you can always use your dash help to see options, like I will say time and time again. So I want to be using some some cool flags. I want to use -I to specify my chain. So I'm going to specify my chain rule. I'm going to be using -p to specify my TCP option. Okay, small p, not this one. Specify the protocol. It's going to be either TCP or UDP. So we're using TCP, so I'm going to specify it here, and then I'm going to be specifying the destination and the destination ports. Okay, so let's do that. Let me show you what I mean. I can clear my screen, and then I'll say IP tables, and then I'll use the capital I to specify my rules. Okay, and remember, either it's firewall or your IDS, they'll typically have rules and actions. Okay, you can say, what rule do I want to apply? Say I want to apply your forwarding rule or input rule, or let me say input chain, for example. In other words, any traffic coming into this network, or from so and so person, and then they will not typically have actions whereby I will say any once this traffic comes in, what should I do with the traffic? Should I block it? Should I stop it? Should I forward it? That kind of thing. So there's usually a rule, and then there's an action, for that rule. So now let me use for this traffic. I want to specify it because it is coming from this. I want to block this this address, okay. But what I want to do is I want to specify a forward chain. Okay, I want to specify a forward chain because during routing, okay, it's good. This thing can happen during routing. So that's why I'm saying forward. Okay, I'm specifying my chain as forward. Then I'll say I want to use the TCP protocol, like I've showed you now. And then I want to say for the destination, I want to use 209.165, as you can see here. 209.165, and then 202, and then 202, and then 133. Okay, after this I want to specify my ports, because if you put only the IP address, you need to specify the exact port of where the user is going to be, because sometimes one service might or one host can have so many services, and the fact that one service is bad does not mean the entire thing is bad. So this 66 is linked directly to the malware server. Okay, so it does not matter because there might be another good service running in the same host. So this dash port is going to specify the exact server that is that's malicious, which is this one now. So I'm going to specify my malicious. I'm going to specify the port, which is quadruple 6, and then I will say I want to perform an action on this. So what action should I perform now if I happen to get this kind of traffic? I'll say I want to drop it. Okay. In other words, don't connect to the person at all, right? So if I press enter now, and if you typed in your commands correctly, it should execute without any errors. Okay, without any errors. And now that we've executed this, let us just recheck our IP tables, lists, chain lists. You get what I mean? So let me show you. let's type in IP tables, and then we want to list the chains, and then see what we now have. Now we see that in the forwarding chain we now have any packets coming from from anywhere in the network that is destined to this guy on port quadruple 6, please drop it, right? So anything that has to do with any host at all that is connected, that is trying to connect to this guy, because if I show you the the diagram again, you see this router, every other host is connected to it. Okay, so it does not matter. So now the IDS will be implemented within this firewall itself. So now if this guy tries to connect to this malicious server, it's going to be dropped. If this guy tries to connect, the traffic is going to be dropped. Same thing is applicable to these other guys. Okay, so if they try to to reach this web server, this malicious server, is going to be dropped. Okay, so let me show you now. Now that this thing has been configured, I'm going to try to download it again. Okay, I'm going to try to download it again using H5. So let me show you now. Let me try to download it. Now I'm still specifying the malicious server that I want to download from. Now it's just like as if it has never been downloaded before. So this is the malicious server, and then this is the file I want to download. If I press enter now watch what happens. You should watch what happens here. You see, okay, nothing is going to happen because it's not actually being flagged. Okay, it's not even getting the router is not even noticing it. Okay, that's what's happening. But now watch this host. Now see what's going on here. It's like as if the host is not even available at all. Are you seeing what's going on? It's like as if the host is not even available, because now the firewall is doing its job. Okay, any traffic that has to do with this particular guy, this host on this port, it is now dropping it. Okay, so you can stay here forever. It's not going to download. If you see these other ones, it didn't even take how many seconds, see how many milliseconds to download. So you see this, but this guy is going to sleep here, so it's not going to be reachable. So this is simply what firewall will do for you. Okay, firewall will block any malicious traffic, any traffic at all. You can just stop it, and then stop it in its track. So I hope you've really enjoyed this section, and then I hope you've learned a lot too. So keep practicing, keep learning. Please stick with us, subscribe, and then any further questions, you let us know in the comment section below. So thank you so far, and then remain blessed. Peace.